Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 3, the applications of differentiations. And this is the video number 3 for the lecture number 22, summary of curve sketching. So the last video, we're going to talk about another kind of the asymptote. We call this the slant asymptotes here. Okay, let's go to our lecture handout to see. Okay, so let's take a look. What is the, the slant asymptotes here? Okay, so like, from the previous when we do the graph, right? So we talk about we have a horizontal asymptote. So what is the horizontal asymptote? So we said that means you have approach what? You approach kind of horizontal lines here, right? So like your horizontal asymptote could be, so for example, could be a function and go like this, right? So getting closer and closer. So this is a horizontal asymptote. And we also talk about, we also talk about the vertical asymptote. So what is the vertical asymptotes here? The vertical asymptote we talked before is like, so my graph is going to approach to what? Approach to a vertical lines here, correct? So you remember that? Okay, so that means now my graph can go like this way, right? Or can go this way here. Right, so those are, we call this the vertical asymptote and the horizontal asymptotes here. So the horizontal asymptote, you approach to a horizontal line. The vertical asymptote, you approach to a vertical line. So what is the slant asymptote? That means instead of approaching to the like horizontal or vertical, the slant asymptote is something like this. So you will have lines here, okay? So you will have some like the lines here. Then your graph are going to approach to this line. So maybe your graph is go like this and then getting closer and closer to this line. So that's what is we call the slant asymptotes here. Okay, so now let's see how do we define it. Okay, so we know the slant asymptote is your approach to the lines here. So let's write down the definition. So we say, this line, we use the y equal to the mx plus b. So if this line is a slant, so if this line is a slant asymptotes here, then that means here, hold on, see here. Okay, so if this is a slant asymptote of the function y equal to f of x, that means, okay, so that means for here, limit when the x approach to infinity or negative infinity, then my function minus this line, that means my function and the distance between my function and this line is going to equal to 0, or you can approach to from the negative signs, right? So it's an x approach to the negative infinity, then the function f of x minus this is mx plus b, that's the line. This one is approach to what? It's approach to zeros, right? So that how do we define the slant asymptote? So that means the function and this line we're getting closer and closer here, right? So it will be very close to 0. So let's take a look like the examples here. So let's take a look at this ones here. right? So if I have a slant asymptote is in here, so if this is y equal to the mx plus b here, so then my function here, my function, so for example, if my function go like this, right? So this is y equal to the f of x. So as you can see, when the x approach to infinity, and this function getting closer and closer to these lines, right? Okay, so the other side, if you go to the negative infinity, let's see what happens here. So let's see here. So if this is my, this is the y equal to the mx plus b. And then if my functions look like here, let's try to see here if my function go like this. Okay, so like in here, like this one's here, right? So when the x approach to the negative infinity, and then you will see here, you know, the function and the line, they were getting closer and closer to zero, just like in here. When the x approach to the positive infinity, then this function getting closer and closer to this line. So we will say this line is a slant asymptote. So typical, how do we do the slant asymptotes here? Okay, so first things here. So like for examples here, if you have if you have like a function, it's like rational functions here. So you have x squared plus x plus 1 and over x. So what we can do here? So we can use here. We can use the long divisions, right? So I can use the long divisions to find the lines here. So what that means here? So let's take a look at here. So if this one's here, right? So this is x squared plus x plus 1 divided by x here, okay? And then in here, we said that this is, so this is x, right? So if you remember the long division, this is x, so this is x squared, correct? Okay, so now you minus it. So this will be the x plus 1, and then you plus 1 here, right? So it's 1 over x, so this is x, and then you minus it, and this is 1 here. So I know this function you can write as the x plus 1 and the plus the remainder terms, right? So remainder term is 1 over x here. Then we know these lines here, so we know the y equal to the x plus 1. So we know the line y equal to the x plus 1 is the slant asymptote. You will say, why? Because I can say here, if I set a limit x approach to 0, right? I try to use my slant asymptotes formula. So it's f of x minus mx plus b, right? Minus x plus 1. And let's take a look here. This is limit x approach to 0. And what is f of x? F of x is here, right? So this is x plus 1 plus 1 over x minus x minus 1. See here? So then the x cancel. And then you let the x approach to infinity. What happens here is will be 0 here, right? So that is why I know the y equal to the x plus 1. This is a slant asymptote. Okay, and then the same ways here, the same slant asymptote, if you let limit x approach to the negative infinities here, so you will have the same values here. So this is a negative infinity. Then you still have x plus 1 plus 1 over x minus 1. So it's still going to approach to zeros here, right? So that means that y equal to the x plus 1 slant. Okay, so that's you know, either side. Then you said, okay, what is this one going? You know, like you could have some things, right? So you could have something like this, depending on what is your function, x plus 1. So the here and here, right? So this is your slant asymptote. So your graph could go like, depends on what is your, your graph going to looks like. I did not graph it, so, but so could it be like this and go like this, right? Okay, so that means that the, you know, when the x approach to the positive infinity, this graph will be closer to here. X approach to negative infinity will approach to here, right? So that's what is, we call it the slant asymptote. Okay, now let's take a look at number 5. This one is interesting. So you said draw a graph, any kind of the graph, and you will have the two slant asymptotes, they will parallel to each other. Okay, so let's see here. So let's see here, if I have, this is one of my asymptotes here, and other one is here, right? Okay, so just for example, then can I find the function? Yeah, so I can do like something like here. So this one, and go like this, right? So that means when x approach to positive, they go to the one end, right? So this is the end going closer to 0. When x go to the negative, they go to this end, right? So that you can find two slant asymptotes and they can parallel to each other. Okay, now let's take a look at number 6 here, right? So the number 6 here, they said, hey, you know, show this one has two slant asymptotes here, and this is not a rational functions here, okay? And now we, you know, so what could this one be here, okay? So now let's take a look, how do we do that? So the first here, so we said for these functions here, if for the, you know, if I have a very large x here, very, very large, then the square roots of the x squared minus 4 really will be very, very close to the square roots of x squared, correct? And so I know that means then this ones here will be equal to the x. Okay, so let's, okay, so now that's why we said maybe y equal to the x. This will be the one of the slant asymptotes here, right? So because this is not like the rational function, we cannot use the long division. So maybe that's why here we say, okay, because when x approach to very, very large to the infinity, then this one will just be approach to the x. Okay, so now let's see if this is the slant asymptote. So use our definition. So when the x become very large, so it's approach to the infinities, right? And then with the f of x, this is x squared minus 4, then minus mx plus b, so minus x. So remember, right, we did this in our limit unit. We said, oh, so if this is infinity minus infinities here. So we said this is infinity minus infinity. And so this is indeterminate. So you guys still remember how do we do the find the limit? We say for this situation, x approach to infinity, and because it is the square roots, so what is the trick we can use or technique we can use? We can times what? Times the conjugate, right? So I times the conjugate. All right, so I'm sorry here. So this is x, right? So here, okay, so I times the conjugate. So here, this is x squared minus 4 plus x here, right? So remember that's the technique we use if I have a square roots, right? Okay, so I times the conjugate. Now, after you times the conjugate, then this one would be the limit x approach to infinity. And then this one is x squared plus 4, minus 4, I'm sorry. So this is x squared minus 4. So this is x squared minus 4 plus x. Then this is a squared minus b squared, right? So it's a minus b times a plus b. So it's a squared minus b squared. See here, then the x can cancel. So what you have here, you have limit x approach to infinity. Then here you will have x squared minus 4 plus x to the negative 4. So what happens here? So for these numbers here, right? So this bottom going to approach to what? Approach to infinity. So 4 over the infinity, what is here? Is 0 here. All right. And so that is that's why we know the y equal to x is one of the slant asymptote. Okay, now the second one is here. Let's take a look. Let's say if the x is a very large, like in the negative number, I mean the large, that means it's very negative numbers, right? So then the same things here, x squared minus 4 should be very close to the x squared. So now I know the x squared, because this is x is very large negative, it will be the negative x. So I said, y equal to the negative x. This could be another slant asymptote here. Okay, so now let's do the same things. Let's try to prove it, right? So this is x approach to the negative infinities, right? So this is x squared minus 4, then minus your mx plus b. So this will be equal to the limit x approach to negative infinity, x squared minus 4 plus x. Correct? So this is x minus 4 plus x here. Okay, so now you've put the negative infinity in here, so you will have infinity. What happened here? You will have infinity minus infinity, because the x is negative infinity, right? So it's indeterminate. So we will use the same methods, try to times the conjugate. Go to the negative infinity, so this is x squared minus 4. Okay, so, oops. So what happens here? So what happens? Okay, so this will be x squared minus 4. So I think hold on. Okay, sorry, I think my internet was acting out a little bit. Okay, so now I times the conjugate, right? So this is x squared minus 4 minus x, and this is x squared minus 4 minus x here, right? So let's do the same thing. So this is x approach to the negative infinity. So this is x squared minus 4 minus x. So this is a squared minus b squares, right? So you will do the same things here. So this will be limit x approach to the negative infinity to the negative 4. And this is x squared minus 4 minus x. Okay, so in here, the x equal to the negative infinity, this is infinity. So the negative infinity, and then have a negative sign, so it's a positive infinity. So the denominator become positive infinity. So what is all these things here? This is an approach to zeros here. So I know both here. So the both y equal to the negative x and y equal to the x, they both are the slant asymptotes, for this graph here. So, if you want to graph it, so this graph is something look like this. Okay, so y equal to the x, so it's these lines, right? So this is y equal to the x. Y equal to the negative x is here, right? This is y equal to the negative x. Then if you just graph the function, so your function going to be something like this. Okay, so that's why you have two asymptotes here. All right, okay, so that's it. And that will cover this lecture, the summary of the curve sketching. So for the slant asymptotes, basically you want to find any line. So it's not a vertical and horizontal line anymore. So it will be any line you can find, and that's what we call it, the slant asymptotes here. All right, that's it. And looking forward to talk to you in our next topic. Okay. Okay. Bye.